welcome to the Deep Dive. Today we're tackling something pretty fundamental, a cornerstone of human history, how we started farming. I think many of us, we picture it as this desperate moment, right? Scarcity, hardship. Some people even called it humanity's worst mistake. But what if that whole narrative is, well, wrong? At least for one really significant part of the world. We're diving into some fascinating new research today, especially a study that just came out in PLOS1. It's a big deal, peer-reviewed, very rigorous stuff.
Right.
And it really flips the script on how our ancestors transitioned to agriculture in the ancient Andes.
The Andes, yeah. A unique place.
Totally.
Yeah.
And the central finding is really counterintuitive. It suggests that in the Lake Titicaca Basin, this massive shift wasn't about suffering or dietary collapse at all.
Okay. So what was it about then?
Resilience. They seem to have maintained incredibly stable diets for thousands of years, showing real economic innovation.
Thousands of years. That's quite a claim against the standard model.
It is. So how do we know this? Well, the researchers used some pretty cool techniques, mainly analyzing stable isotopes from ancient human bones.
Ah, the isotopes.
Exactly. And they backed that up with evidence from, plant remains, animal bones, the whole archaeological picture. It's like historical forensics, piecing together ancient meals.
That makes sense because the established view, the one you hear most often, it really does paint a different picture.
It does, doesn't it?
Yeah, it usually argues that growing populations and shrinking wild food sources basically forced people into farming.
Right, like they had no other choice.
Exactly, and that this usually meant a period of, hardship, worse diets, more work. That's the classic story you find in textbooks for many regions.
But this new study, the one by Luis Flores-Blanco and his team, published just June 25th, 2025, it really throws a wrench in that for the Andes. They flat out conclude it was a time of economic resilience and innovation, not hardship. So what exactly did they look at? Where did they find this evidence?
Right, so their work focused specifically on the Lake Titicaca Basin during that key transitional time. They looked at two main sites, Caicaro and Jiscayromoko.
Okay, I've heard of those.
Yeah.
Known for good preservation.
Excellent preservation, yeah. And crucially, they were occupied pretty continuously from about 5,000 to 3,000 years ago, right through that period where agriculture was developing.
Perfect timing.
Exactly. And what they started finding right away was surprising, to say the least. It didn't fit the old model.
Yeah, I saw a quote from one of the co-authors, Luisa Nostroza. She said the findings challenged the traditional idea that the transition to agriculture occurred out of necessity or periods of crisis. That's a pretty big statement, isn't it? It kind of reframes how we think about progress happening, maybe not always driven by disaster.
It absolutely does. And when you dig into the details, the how, the isotopic evidence, is really the star witness here.
The isotopes again. Explain those a bit more. How do they tell us about diet?
Sure. So they measured carbon and nitrogen isotope ratios from the bones of 16 individuals. Carbon isotopes tell you about the types of plants people ate.
Like C3 versus C4 plants.
Precisely. C3 plants were things like quinoa and potatoes, which were common in the Andes. C4 plants like maize weren't really a big part of the diet there until much later.
Okay. And nitrogen.
Nitrogen isotopes tell you about their trophic level. Basically, how much meat versus plants they were eating. Higher nitrogen usually means more animal protein.
Gotcha. So it gives you proportions.
Exactly.
Proportions.
And the amazing thing about isotopes is they reflect long-term dietary averages. It's not just what someone ate last week, it's their staple diet over years. Yeah. A direct window.
And this is where it gets really wild, right? The consistency.
Astonishing consistency, yes. Their analysis showed diets with a really high proportion of C3 plants, about 84%.
84%. Wow.
Yeah. And this was supplemented by a smaller amount of meat, mostly from large mammals. But here's the kicker. These proportions. They were basically identical to earlier hunter-gatherer groups in the same area, people living way back between 9,000 and 6,500 years ago.
Identical. No change.
They were also identical to later fully farming communities in the region, too. The average isotopic values just stayed remarkably stable for thousands of years.
That completely contradicts the crisis model, then. You'd expect less meat, maybe a shift to less desirable foods.
Right. But nope. The best fit Bayesian model, that's a statistical way they confirm these things, points to about 84% C3 plants, only around 8% meat, maybe 4% fish, and C4 plants like maize. Tiny. just 2%.
So no sign of dietary stress in the isotope data. Very clear.
Very clear.
But isotopes are one thing. What about the actual stuff they dug up? The animal bones, for instance. Did they tell the same story?
They did, remarkably so. The zooarchaeology, the study of the animal bones, showed a consistent focus on large mammals.
Like what?
Primarily camelids, think llamas, alpacas, and cervids, which are deer. Very few small animals, birds, or fish showing up.
Interesting. And you mentioned sites changing over time.
Yeah, and what's intriguing there is that the proportion of camelids goes up compared to deer at the later sites. At Kayarudo, it's 85% camelid among the large mammals. At Jiscayromoko, it's 90%. Suggesting early animal management, maybe not full domestication yet, but definitely managing herds. Proto-domestication, you could say.
Okay, so managing animals.
Yeah.
But they were still hunting too, right? You mentioned projectile points.
Oh, absolutely. Hunting was still clearly important. They found lots of projectile points, and almost all the animal bones found were burned or had cut marks.
So definitely food.
Definitely food. These animals were being processed and eaten.
Okay, so stable meat intake, maybe shifting how they got it slightly towards managed animals. What about the plants? What do they find there?
That's equally fascinating. The archaeobotanical evidence the plant remains showed that charred chenopod seeds, which are related to quinoa, were the most common plant find at Kayaturo.
Chenopod's, okay.
And at Jiscayromoko, they actually found potato starch grains directly on grinding stones.
Wow. Direct evidence of processing potatoes.
Yep. Suggests pretty intensive potato use and possibly moves towards domestication. We know wild tubers, likely potatoes, were staples there way back in the Middle Archaic period.
So, again, it's not a sudden, desperate shift to new foods, but maybe intensifying the use and management of existing staples like tubers and quinopods.
Exactly. They were intensifying and managing specific plants, maybe domesticating them or starting down that path, but it didn't cause this huge upheaval in the overall diet structure, the plant versus meat ratio we saw in the isotopes. It was more like integration, not replacement.
The study mentions being cautious about tubers sometimes not preserving well, right?
True. Preservation can be tricky for tubers, but the overall pattern points towards tubers being important throughout, with quinopods also becoming really significant.
Okay, so if it wasn't a crisis, how did they manage this stability? During what we think of as such a disruptive period, adopting agriculture, how did they thrive?
That's the million-dollar question, isn't it? And the authors suggest it wasn't just about food, it was enabled by a whole set of cultural and technological innovations happening around the same time.
Like what?
Well, things like expanding trade networks. They found non-local stuff like obsidian coming in.
So they weren't isolated.
Definitely not. They were connected, exchanging goods, ideas probably. That gives you flexibility. And we also see innovations in ceramics popping up.
Pottery. Crucial for cooking and storing grains and tubers, I guess.
Absolutely crucial for processing these plant foods more effectively. But one really interesting idea they propose involves archery technology.
Archery? Bows and arrows? How does that fit in with farming? Seems a bit random.
Well, think about it. It could have had a couple of big impacts. First, maybe it just made hunting more efficient.
So even if animal numbers dipped slightly, better tech meant they could still get enough meat. Maintain that stable protein intake.
Potentially, yeah. A more reliable way to get protein. But the second idea is maybe even more profound. They suggest archery might have improved social control, maybe reduced raiding between groups.
How so?
Well, better long-range weapons might change conflict dynamics. If things were more stable, less raiding, that creates a more secure environment where investing time and effort into food production farming actually makes sense. It reduces risk.
Huh. That's a really interesting angle. Creating social stability through technology allows for economic stability and change. I hadn't considered archery playing that kind of role.
It's quite thought-provoking, isn't it? Makes you think about technology's wider impacts.
Definitely. And you mentioned the camelids before. They were important beyond just meat, weren't they?
Oh, hugely. They weren't just dinner. They were wool, hides, pack animals for that trade we talked about, carrying obsidian, maybe salt, other goods.
Right.
Their dung was also super important as fuel, especially up on the high Altiplano where trees are scarce.
Good point.
And the study even hints they might have been used in ceremonies or as a way to show off social status, costly signaling. Owning lots of camelids meant you were important.
So a whole package deal. Explains why they stay so prominent in the archaeology, even if they weren't the #1 source of calories, according to the isotopes.
Exactly. Their value is multifaceted.
So putting it all together, it wasn't this simple straight line from hunting to farming. The authors call it more like a mosaic or a rhythmic process.
Yeah, gradual, non-linear. They were integrating domesticated crops slowly, managing animals, but not immediately abandoning wild foods or hunting. It shows incredible adaptive flexibility, doesn't it?
It really does. So what does this all mean for, our big picture understanding of human history? This deep dive really shakes things up.
I think it fundamentally challenges those overly simplified, crisis-driven stories about how agriculture began. We tend to default to that narrative.
Yeah, it makes you reconsider what drives major change. Maybe it's not always desperation. Maybe it's resilience, innovation, this kind of flexible adaptation, finding stability even while things are shifting.
Right. Our ancestors weren't just passively reacting to crises. Here, at least, they seem to have been actively shaping their transition, strategically adapting, and, well, thriving.
And the long-term consequences were huge, right? This stability wasn't just a blip.
Absolutely not. This incredibly resilient foundation, built over millennia, is likely what allowed for the later rise of complex societies in the Andes. Think Tiwanaku, think the Inca Empire. They didn't just spring out of nowhere.
They built on this long history of successful adaptation.
Precisely.
So what can we, listening today, take away from this? Does it teach us anything about societal transitions now?
I think it encourages us to look for different patterns. Maybe not all big economic shifts have to be disruptive crises. Perhaps some societies adapt through stability, through clever integration, not just struggle.
It makes you wonder about the changes we're facing today, like with technology or climate.
Yeah.
Are we maybe too quick to label everything a crisis? Could there be slower, more resilient adaptations happening underneath, like in the Andes?
It certainly suggests we should be open to that possibility. We might need to look past the immediate disruption and search for signs of underlying resilience and gradual adaptation, rather than just assuming collapse or hardship is the only path.
So to quickly recap, the Andean Altiplano gives us this amazing picture. Agriculture emerging not from crisis, not from famine, but growing out of thousands of years of stable, resilient life, boosted by some smart cultural and tech innovations.
Yeah, a remarkably different story.
And it leaves you thinking, if a change as huge as starting farming can have this surprisingly stable, resilient pathway, what other big crisis narratives in history might be, well, incomplete?
Right. What other stories of human ingenuity and adaptive flexibility are hiding there, waiting for us to find them? Especially if we can resist the urge to always simplify these really complex moments in our past.
Definitely something to mull over. A hidden history of resilience. Fascinating stuff.